Yo, what's going up, guys? Today we're going to learn about Hardhat framework, which is widely used in smart contracts. Hardhat makes developer to test their smart contracts on forked Ethereum network in both local and live. We'll be also looking into some other helpful libraries like ether.js and chai. Ether.js helps frontend to easily communicate with deployed smart contract, and chai is used to check whether the deployed contract is valid or not. We'll be going step by step, so bear with me. And without further ado, let's dive into it. Okay, so before we start coding, I want to show the overall flow of how all these things work in place. First of all, we should write smart contract with Solidity language, and then we should compile the smart contract by using Hardhat framework into the bytecode. The reason why it should be compiled into bytecode is because the Ethereum virtual machine is not able to read the pure Solidity language. After it is compiled into bytecode, then the Ethereum virtual machine deploys to the local, test, or live network. After the contract is deployed, then the user is able to interact with the deployed contract by using front-end framework like ether.js and web3.js. First, we should install Node. Node is a JavaScript runtime environment. I'm personally using Mac OS, and Node is already installed in my computer. For ones who use Mac OS, I definitely recommend installing Node using Homebrew, and for Windows using Chocolate Tree, which both of them are called command line application. If you use them, you don't have to manually set the path for executing Node. After installing Node, you could check whether the Node is installed correctly or not by typing node-version on your command line. Yeah, for me, it's installed properly. After the Node is installed, you should make a folder where your Hardhat contract, where your smart contract will be written. So I'll make my folder in desktop. Name it as Hardhat tutorial. And move the change the directory to the Hardhat tutorial and open up with Visual Studio Code. Now, after you made a folder, you should open up a new terminal inside this folder and initialize with npm. Check everything with pressing enter. After you initialize with Node Package Manager, you could find package.json has just created. Now you install Hardhat. It should take some time installing it. Okay, I think it took about 1 or 2 minutes to install Hardhat. And then you execute the hardhat with npx command. Create an empty hardhat config.js. Make contracts folder in your root directory. And make solidity file called token.sol inside there. First, we should specify the solidity version by using pragma keyword. We're going to use 0.8.9 version here. And for SPDX license identifier means like what are you going to deal with this smart contract you've written now. Like it could be public, commercial, or open source license. We will be using MIT license here and make a contract named token. You're not going to dive deeply in the grammar of solidity, so I'll be swiping it very fast. Make state variable. Name my hardhat token and symbol for MHT. Make u int 256. Variable name total supply is 100,000 and make owner variable public. By the way, this address type variable is very special in Solidity. It acts crucial functionality in wallet. Make mapping address key as address type and value as UN256 and make it as balances. And also make event transfer and next where you're sending money from, where you are sending money to, and the transferred value. And now you should make a constructor. Franklin's TR. This constructor is first initiated when you make this token contract. It is not activated by someone else who just call it. So make sender as total supply and owner should be the one who initiated this token contract. Okay, and we should add some basic functions here. Input parameter would be address 2 int 256 amount and make it external so anyone could call this function from outside. This require statement is to check whether this condition meets or not. If it doesn't meet, it reverts it and prints out this statement on the debug console. When this condition meets, and when this condition meets, it doesn't revert and executes the next line. So we should subtract from the money sender, and the money receiver's balance would be updated by the amount. Message not, oh, that's sender to, oh, to amount. And then we should make a function that simply checks the balance of the input parameters address. Also make it external. A view is also a special keyword that doesn't need gas and just reads from the Ethereum blockchain. Returns uint 256 data type and returns balances. Okay, so check whether there's no typo here and save it. And after we made this contract, we should compile with Hardhat. Yeah, and you could know that the compiled file is downloaded in this artifacts folder. After we compile the token solidity smart contract, we should check whether the deployed contract is valid or not. In order to do that, make test folder, and inside make let's say token.js. We would use chai library to make test. Get expect from chai, and we would use describe it keyword to test our deployed contract. So I will write first and explain it later. Deployment should assign the total supply of tokens to the owner, and add asynchronous function. Okay, so this describe and it keyword basically means we use describe to set the coverage of code we would like to test, and the it keyword sets to make the unit test. Inside the unit test, we're going to call one address, Every method that is called from the ethers library returns future, since it is all asynchronous flow. So this getSigner method returns the list of address that is currently connected to the node. Since there is just one object, which is owner, we get only one address. And we instantiate token from getContract factory. We're doing this to actually deploy from the token that is made from this getContract factory. It is kind of the design pattern, which is factory method. It gets the token. This token, it would be the same name as the compiled file. So it takes this name and returns an object. And we're doing this because we're going to deploy this token and get the Hardhat token. After we make this, we will be able to call functions inside the smart contract. So as we can see, we're calling balance of. We're calling the balance of function and putting inside the return value inside the owner balance, and we make a sanity check that the actual total supply is equal to the owner.balance we have just retrieved. Okay, seems like you're done. Oh, and I think I forgot to mention, you should install pm install this Nomic Foundation Hardhat toolbox in order to just use this ether library. We're using this sudo command to ignore like internal warnings of Mac OS. And while it is installing, we should import toolbox here. Okay, so let's make a test. Hardhat test. Oh, deployment should assign the total supply. I was spending some time to find out where I was wrong first. you should change the get signer to get signers plural, and I put the dot here before. You should definitely erase it. After changing this and make the test, you could find out that it actually passed the test here. Now let's actually deploy it to a live network. First, we need to write a deploy script, and then we should modify some hardhat.config.js. Let's first write a deploy script. Make a new directory called scripts, and make deploy.js inside it. Let's make an asynchronous function and make a new deployer object. Ethers.get signers. And let's console.log deploying contract is the account, and let's get the deployer's address, and then let's get the deployer balance, make it to string, then make the token object, get from token from ethers. It looks very similar to this testing object, right? Testing script. Get from the deploy smart contract. Make a token as deployed of the uppercase token, and log it. Token.address. Let's execute the main. Process.exit, and make the error check. Error. And exit it. Okay, let's save it. And we're going to use a network called Goerli. It's a sidechain of Ethereum. First, you need to get a Goerli token from Goerli faucet. It gives a free Goerli token to your MetaMask wallet. MetaMask wallet. I have this Goerli Ethereum, so I don't have to use the faucet right now. if you go to the Hardhat configuration, oh, and also we are going to use the RPC URL, one of the RPC URL called alchemy. Goerli. So in here, you should enter the app's API key that you've registered. You're going to be registered from Alchemy. And here, you should put your private wallet address. Next export is we use 0.8.9 version previously. Oh, sorry. So, colon, and you're going to use networks as Goerli. URL is we're going to leave it for now, and accounts as Goerli. First, you could find your private key by clicking this 3 dot here and export this private key. I'm going to blind it when it's going to upload in the YouTube. Paste it here. Oh. And go to alchemy.com. If you don't have Alchemy account, you should make it. It's free, so no worries. Okay, we've made it, and we're going to create a new app here. Let's make it Hardhat YouTube, and you should be sure to make the network as Ethereum Goerli. Create a new app, and click the view key and get the API key here. Paste it here and get the HTTPS URL here and paste it. This backside is going to be the Alchemy API key. So just to make it neat, I'm going to use it like this. Alright, so all things are set and we're good to go. Let's actually deploy it on the Goerli deploy.js. Network as Goerli. Okay. What? Sorry, I've made a mistake before. You should remove the original module exports written somewhere here, and also made the URL as backticks, since so you can use the Alchemy API key as an input. If you write like this URL would be literally this string value. So if you want to use this variable, you should be using backticks, not just quotes. So I've changed this hardhat config.js and executed hardhat run with Goerli network, and it seems like it's successfully deployed. So if you want to check this, you could go to Goerli Etherscan to see what kind of transaction I've made. Copy my wallet's address here, and here, just 2 minutes ago, I've made a transaction. Yeah, so this is it. From this tutorial, you've actually set an environment of writing smart contracts, wrote a smart contract and test, and actually deploy them into a Goerli sidechain. Congratulations!